Hi, I'm going to talk to you today about some exam technique which hopefully will help you avoid losing marks unnecessarily in your maths exams. So obviously you have a quite unique position in that you didn't do GCSEs or exams in year 12 particularly. So this is the first time that you are going to sit down and do a formal exam. And obviously that's going to be really different from tests that you've done in class, even end of year exams that you've done in school. So I am an examiner for Edexcel, so I help mark the A-level papers formally. So you might want to know a little bit about how this works. So it used to be that they literally did it on paper. So you'd have hundreds of papers arrive at your house and you do them all. But now it's all done online. So those things where it says do not write outside these lines, they actually mean that because they scan them all through a big machine. So if you write outside the lines, unless someone spots it, it's possible that that working will not be seen and therefore can't be marked. So it's all done online, and papers are scanned and separated by question. So each question is seen by multiple markers. Usually it's at least 3. If it's a question that is proving really difficult to mark, then it might be seen by as many as 5 different people. The mark schemes are adapted as we go along. So before the marking starts, the chief markers will sit down and they'll write what they think is the kind of rough mark scheme, which obviously has the answers and has any methods that they think might come up. But what will happen is that as we then start marking, there'll be more methods that we hadn't thought of that will then be added to the mark scheme. So sometimes a mark scheme question might have as many as 15 or 16 different versions. So we need to make sure that obviously any correct method that has been applied gets the marks that it's owed. If there are any issues or questions, then they are remarked. And when the last time we marked live papers back in 2019, this actually happened. There was one question that was quite contentious, and it ended up that we just remarked the whole thing. So the takeaway from this particular bit is that actually maths marking is really quite rigorous. So if you send them back for remarks, it's really quite unlikely that you're going to get any significant change because they usually go through so many different people. How many marks are there? So there are 100 marks per paper, and that's across 120 minutes. So that's roughly a mark a minute, obviously not quite. So the most important piece of advice I'm going to give you at the start is look at how many marks there are for a question, because it will tell you a lot about how long that question should take, and that will tell you a lot about what you should actually be doing to answer that question. If it is a 1 mark question, then that means either you already know the answer, as in you can read it off a diagram, or you've just worked something out and you can literally write it down. Or you can deduce the answer from information you already know. So it might be that you've got an equation and they ask you, what does this bit of it mean? So you've already done the work. You are just deducing the answer from something you've already done. Or minimal numerical calculations required. I mean, really minimal. Not a lot of calculations, no method is required. If it's a 1 mark question, then that mark is for the answer only. Now, I was marking a paper for my group last week, and there was a 1 mark question that asked you to deduce the number of solutions to a trig equation, and actually a really complicated trig equation, and a number of them actually solved the trig equation. Now, solving a trig equation could get as many as 6 marks, definitely at least 3 or 4. If they are asking you a 1 mark question, it will definitely not be to solve a whole trig equation. So if you're looking at it and thinking this is going to take loads of time, then you're doing it wrong. You've missed a trick. So either think again about what that trick is or just move on. If it's only 1 mark and you spent 5 minutes thinking about it, that is 5 minutes time that could have been spent better somewhere else. If it's a 2 mark question, one of those will be an A1 mark. So A1 means just 1 mark for the correct answer. So there's minimal method required. At most there'll be 1 method mark. So you are expected to do a little bit of something, but not an enormous amount. A 2 mark question ideally should take 2 minutes. As a general rule, If you've been working on something for more than twice its marks in minutes without much progress, then stop and come back to it later. Now we're going to talk about making better use of your calculator. So the first thing about this is that all trigonometry in calculus, so differentiation and integration, is evaluated in radians. So if you are going to evaluate some calculus, as in find an actual number at the end, and it has trig in it, it must be in radians. So the best thing I think to do is to keep your calculator in radians all the time and change the questions back into degrees when you have to, and then change it back and get into the habit of doing that. There are lots of things that are only in radians in your paper, like the arc length sector area, that has to be in radians. All the calculus has to be in radians. So the majority needs to be in radians. So keep it in radians, change it into degrees if you have to, and then change it back. Get at least this calculator if you haven't already. This is a really, really good one. It does almost everything you need to do. You can obviously get a graphics one. If you're not doing further maths, it's not necessarily that helpful, but the most important thing to say about both of these calculators is that you have to know how to use them, and you have to do that now. There is no point on the day in your exam suddenly thinking, oh yeah, I'm going to check to see if this integral is right, because if you spend 5 minutes faffing around with your calculator, that's 5 minutes you should have been spending on some maths. You can check many of the questions using your calculator. So you can evaluate integrals, derivatives, sums of series. There are loads and loads of things that you can do on here, but you must be doing it all the time. It has to be a habit, because otherwise you'll forget to do it on the day because you'll be quite stressed in the exam possibly. So it needs to become a habit that you finish a question, you check it on your calculator. So all of these things like surds and fractions and logs and luns that you can check the values on your calculator, it has to become part of your everyday working for it to really be helpful in the exam. And obviously, particularly if you've got a graphics calculator, you really need to know how to use it. There's loads of stuff online to help you with this, and obviously your teacher can help you as well. But the exam is not the time to be trying to learn how to do something particular on your calculator. You need to get that sorted out before. So we're going to look now at the issue of multiple attempts at a question. So if you've tried a question multiple times and you've crossed all of them out except for one of them, then the examiner will mark that response. It doesn't matter if you've actually done it correctly somewhere else. If you've crossed it out, they will mark the one that's left. Now, I've seen this surprising amount of times and it's slightly heartbreaking. You can see they've done it right, but they've crossed out and then they've done it wrong, and we can't do anything about that. We can't give you the marks if you have clearly indicated which is your correct response. If there are several attempts and they've not been crossed out, then the examiner will mark the answer which is the most complete. So if we look at these 3 attempts, for example, we can see that the top one is the most complete because it goes all the way to having a +C. Now, luckily for this person, that was actually the most correct as well. So the examiner would take attempt 1 as their final attempt. However, obviously, if attempt 2 went to +C instead, then they would take that one, even though it got them less marks. So they're not going to automatically give you the attempt that was the best. They're going to give you the one that is the most complete, even if that may be one that's wrong. One way to try and counteract this is if you worked in columns instead of one under another. So if you had 2 versions of the same question, if you worked side by side and they were the most complete and one was wrong and one was not, then it's possible that they would take the correct one if there wasn't one that was lower on the page. It's a bit of a grey area, but it would certainly at least get it flagged up and possibly sent for a remark so that someone else could have a look at it. So I would generally say do not cross anything out, because then there's a chance that if the correct working is in there, they will be able to give you the marks for it. If you cross it out, they definitely can't. So if you're going to do multiple attempts, don't cross anything out. Try and make sure everything finishes vaguely at the same place on the page so they can pick, hopefully, the one that's right. So we're going to have a look now more specifically at when and where you can't use your calculator. So what I suggest you do is pause the video now and do this question before we move on. Okay, hopefully you've had a chance to have a look at it. So what we think about is, what is the point? What is it that they're assessing? So the key is in the question here, find using algebra all solutions to the equation. So they are assessing your ability to use algebra here. So obviously what you definitely cannot do is just solve these using the equation solver. If we look at the mark scheme, for part I, there is a B mark. If you look at the bottom, B1, and you get that for just writing A equals 0. You don't have to show any working, you don't have to justify it. An independent mark, a B mark, you just get for writing it down. So obviously you could have done that with a calculator, and that will give you one of the marks. The first 2 marks, the M marks, are for the algebraic manipulation. So you will need to show enough steps to justify getting to the A mark, which is a quarter. So if we have a look at an example of this one, so if we have a look at someone's attempt at this question, this is for part I, we can see that they've done some correct algebraic manipulation. They've got A equals 0 at the bottom, so that will give them the B mark. Now, you can also see that they have clearly used their calculator to solve that quartic equation in the 3rd line from the bottom. So they've got to 64, a to the 4 minus A equals 0, and then they have used their calculator to get A equals 0.25 or A equals 0. Now, this is a real grey area. For this specific question, this would have got them 4 marks because they have done sufficient algebraic manipulation in the start of this question to then get that final A mark by using their calculator. But I think this is a risky move. If I was doing this, I would want to see a little bit more working between that 3rd and 4th step. So I think in general, if you're ever slightly in doubt, do more working. Don't use your calculator. We're going to look at a part II next, which is a really good example of when not to use your calculator. So here is someone's attempt at II on this question. And although they have some algebra down at the bottom, which isn't particularly helpful, you can see that they actually do have the right answers at the top, but they don't get any marks for this at all. Now you might think, but hang on, they got the right answers, won't they at least get the A1 mark? And the answer is no. Because at A level, if you got the right answers, but you have shown incorrect working or insufficient working, they're not going to give you any marks at all. Now it might sound harsh, but they're not assessing your ability to get that final answer. They are assessing your ability to show the skills that are required to get there. So if you haven't shown, in this case, how to solve this quartic, then you won't get any marks for it. So especially a question that literally says in the wording, find using algebra, you have to use algebra. If you can, you absolutely should check it on your calculator. And obviously for this case you can. And at the end you can check it on your calculator so that you know you're correct and you've got full marks, and that's great. But you should never ever be just doing it on your calculator and writing it down. You know that's not worth 4 marks, and they're not going to give it to you. So I would again pause the video, have a go at this question. So let's talk about what is the point of the question. What are they assessing? So part A is assessing whether you can differentiate. That's what you're going to get the marks for. Whereas part B is assessing whether you recognise that for a curve to be increasing, its derivative must be greater than 0. That's the knowledge they want to see. So if we look at the mark scheme, the first mark for part A, you will just get for decreasing the power of the variable, because that shows that you fundamentally know what differentiation should be doing. And then the 2 A marks are 1 for each correct part of that expression. So that's fairly straightforward. For part B, that first method mark is just for setting your derivative to be greater than 0. So that mark is for just knowing that a curve is increasing means that the derivative is greater than 0. So even if your derivative is wrong, you will still be able to access that mark. But notice it says, it has the little arrow pointing to x is greater than. So you not only have to do it, you have to attempt to solve it. You don't have to get it right, But what's also important here is that you do not have to solve that yourself. You can solve that inequality using your calculator, because there is one method mark, and that method mark is for recognizing that it's increasing and what that means. It is not for the method of solving the equation. And then the final answer is just for the answer. So if we have a look at someone's attempt at this question, then we can see on part B that they set up their equation, and we get down to 6x cubed minus 24 equals 0. And we then get an answer, x equals 1.587, 3 decimal places. Now, obviously, they have solved that using a calculator. They have put that cubic into their calculator. Now, unfortunately, they don't actually get the A1 mark for that. Have a think about why. Think about what the question was. So it wanted an exact answer. So although 1.587 is correct, they don't get the A1 mark because it's not exact. They wanted the cube root of 4. So what's frustrating about this is, although they were totally justified in using their calculator to solve that equation, if your calculator doesn't give you the answer in the exact form, it hasn't really helped you. So in this case, it would have been better just to solve the cubic and then perhaps checked it on your calculator. But the thing to take away from this is that that M1 mark did not require you to solve that equation algebraically. You could have done it on your calculator. Unfortunately, in this case, that hasn't actually helped very much. But the main point of this question of part B is not, can you solve a cubic equation? It is whether you understand whether an increasing function has a derivative greater than 0. So every time you look at a part of a question, you should be thinking, what is the point of this question? Is the point, can I solve an equation? Or is the solving equation just part of solving a greater problem? So let's think about this more generally. If you have a question where solving an equation is not the main point of the question, so the question isn't literally, can you solve this equation? You are setting up and solving an equation as part of a bigger picture, then you can use a calculator. One of the most common examples of this is in mechanics. If you end up with a quadratic when you're solving a SUVAC question or a forces question, if you end up with something that has a set of simultaneous equations or a quadratic equation in a mechanics question, you can almost always use a calculator to solve that. Because a mechanics question is not concerned with your ability to use algebra. It is concerned with your understanding of the mechanical situation. So that is a fairly certain time in which you can use your calculator. With pure topics, it's a little bit trickier. If in a trig question, for example, you end up with a quadratic, you're fairly safe to use the calculator for that one. But I would say it is always safer to do it by hand, because you cannot guarantee that you're going to be able to do it with the calculator in the question. So if in doubt, just do it by hand, but obviously then use the calculator to check that you're correct. If it's a 2 or 3 mark question, and that 2 or 3 mark question involves solving an equation, it's unlikely that there will be method marks for the solving of that equation. That is another way of thinking about it. So if there are 2 or 3 marks, and it's not a 2 or 3 mark question on solving equations, then you are likely to be able to use the calculator to do that. So use the equation solver. Make sure you know how to use the equation solver, because it can be really helpful. But again, cannot emphasize this enough. If you're ever in doubt, just do it yourself by hand and use the calculator to check that you're correct. I mean, solving a quadratic or a cubic, it shouldn't be that onerous. It's not going to take you that long. So if in doubt, use the calculator to check, but don't just write the answer down. Just a quick point about this question. So again, pause it, have a go at the question. So here's the mark scheme, and you can see that for A, B and C, they all specify that the answer is in tons. And if you see in yellow that I highlighted at the bottom, this is from the mark scheme, that they will withhold the mark if you don't put tons. But they'll only do it once, which is quite kind, so you don't lose all 3 marks. But you will lose one of them if you don't write the unit. Now at GCSE, they often put the unit on the line, But at A level, you are expected to give the unit. So if it's a question, and usually it's a question that's in context, like this one, you must give the unit, or you could lose a mark. Now, I know 1 mark doesn't seem a lot, but actually it really does add up. These kind of silly mistakes add up to make quite a big difference. So if you're working out an answer and it is in a unit, you must state the unit. So again, I would just pause and have a go at this question, and you can see the mark scheme that's on the right. So there's lots of parts to this question. It's really only part A that I'm interested in for the purposes of this section. So it says prove that x minus 4 is a factor of f of x. So you can see in the mark scheme that the first mark is for some method that's appropriate. So this is either going to be subbing in 4 using the factor theorem, or it could be using algebraic division. So if you've attempted to do that, that will give you the first mark. If you notice for the second mark, for the A mark, it clearly states f of 4 equals 0, therefore x minus 4 is a factor. So to get the second mark on this, you must make a statement explaining why x minus 4 is a factor, and you must relate it back to information that you found. The key word in that question really is prove. If they're asking you to prove something, you must end that with a statement saying, I have done this, and why you've done it. So let's look at an example. So here are some examples of people's work. So it is not enough to get both marks to just show that f of 4 equals 0 or divide by x minus 4 and get no remainder. You have to state a conclusion. And it has to be a really explicit conclusion. So if you look at the first example, they've done their working and then they say therefore x minus 4 is a factor, but they don't actually get the second mark for that, because they have to say that f of 4 equals 0, therefore x minus 4 is a factor. I know that might seem really harsh, but actually they've done some working, but they have in no way explained how that working leads to their conclusion at the bottom. So they need to show that they understand that because when they substituted 4 in it became 0, that means x minus 4 is a factor. So the bottom example shows really well how you should do this. So you put your 4 in, you get f of 4 equals 0, therefore x minus 4 is a factor. Now another really important aspect of this type of question is that this one just said prove that it is. Sometimes you will get a question that says show using the factor theorem that x minus 4 is a factor. Now if you do not use the factor theorem, you will not get any marks. If you do algebraic division, even though you have shown that x minus 4 is a factor, you will not get any marks. You have to answer the question they've written down. If they are asking you to use the factor theorem, then you have to use the factor theorem. I know it sounds really harsh, but actually they're being very clear with what they are assessing. They want to see your ability to use the factor theorem, so you actually have to do it. So let's have a look at some trig. Now, show that our questions are really common with trig, which is quite nice because you know if you've got there. And also they usually lead them into an equation afterwards. So looking at this one, again, I would pause it, have a go. The mark scheme's there for you to have a look at. So let's just have a think about that part A. Now for the final mark on this, you must have a fully correct proof, but it must have the correct notation. Obviously no errors, that's given. So they will withhold the last mark if you have a mixed variable, as in sometimes you're writing theta and sometimes you're writing x, or if you have poor notation. So if you write cos theta squared without the bracket, interchangeably with cos squared theta, because they're not the same thing. Or if you write sine squared but without a variable. So you have to be really precise and you have to be really careful about how you're writing this down. If you're missing variables or you're mixing variables or you're not writing it down mathematically correctly, then they will take that final mark from you. And it's a shame because if you've done everything else right, then you deserve the full marks, but you have to be neat enough with how you're writing things down. Now with trig, show that questions more generally, just show maximum working when you're doing trig proofs, because obviously you're given the answer. So all the time students try and fudge it. They try and style it out to get from the start to the finish. And we will notice we have to go through these literally line by line very carefully to make sure that you're doing it correctly. So you have to show maximum working. Don't skip any steps. Show every single thing you're doing to give yourself the best chance of getting all of those marks. Now, a particular thing to do is if you are ending up with a sine over cos, you must write the sine over cos. Don't just skip straight to writing tan x, because they need to see how you've got from that step. They need to see that you know that sine x over cos x is tan x, not that you've just guessed that it has to be tan x because there might be a tan x in the answer. That is one point that they will take that mark off you if you don't show that. And be really precise with your notation. It's so easy to miss the x off the end of a sine squared if you're in a hurry. And just make sure your work is laid out really clearly and really neatly. Obviously, in Examiner, we try really hard to read everything, but it is really difficult sometimes if the handwriting is really poor, or if it's laid out really badly and we're just really struggling to follow it. It makes it a lot harder for us to give you those marks that you should be getting. And coming back to show that questions. So, I mean, this is worth 7 marks. This is a huge question, and you have the answer. So you have to show so clearly that you understand every move that you're making. Now, a really key thing here is this line underneath. Solutions based entirely on graphical numerical methods are not acceptable. Now, it says entirely there, so that does imply that there is some range for numerical methods to be used, as in a calculator, but that is really very limited. They are expecting you to show clearly, algebraically, how you are solving this question. So again, pause it, see if you can do it. And then here is the mark scheme. Now what's interesting here is that you can see that for this method mark, so you're setting the derivative to equal 0, you're forming that equation, and you're solving it. Now they are clearly showing an algebraic method there. So I would be very surprised if you used a calculator to solve that they would give you that mark. They are expecting you to be using algebraic methods. And then interestingly, for the A mark on the top one, you need to show not only that you've chosen 4, but that you've disregarded x is 5/3. You need to make it clear you understand why you're not going to use that one. And then in the second part of the question, you must show that you understand what it means to evaluate that integral. So even though once you've integrated correctly and you're going to put in your limits, you could just put that into a calculator, as in you could work it out using a calculator. But you have to show in your working that you have put the 4 in. You don't have to show the 0, although I would, just out of habit. But unless you show that you've put that 4 in, you will not get the final mark. You cannot go from the B line where you've integrated straight to the answer. You have to show that you understand what it means to evaluate an integral, and that means writing that line with the 4 in. Now this is an interesting one. So this is someone's attempt at this question, which they've done pretty well at. But you'll notice that here, their integral does not have a dx on it. And that is the only place that they have written an integral in the whole question. So highlighted in yellow from the mark scheme. For correct notation, so again, the last mark is for correct notation. They need to see the derivative sign used correctly at least once. So they've done that, that's fine. And they need to see the correct integral written once, with or without limits. So they've put the integral, but they haven't put a dx on the end. And so they will lose the last mark. Even though everything else they've done is right, they will lose that mark. So make sure that you are at least once, and preferably all the time, writing down the correct notation and using it correctly and writing it out in full. And again, this is not the kind of thing that you can be like, I'll remember on the day. You need to be doing this all the time. Whenever you're working in homework, in classwork, you need to be making sure that you're using the correct notation. So let's look at a proof question. So the first thing to notice for this one is that the final mark of this 4 will be for just stating your conclusion. You have to say at the end, therefore n cubed plus 2 is not divisible by 8. But the wording of this is so important. So if we look at this example, at the bottom they say 8 is an even number, therefore odd numbers can't be divided by 8. Now that's not true. Anything can be divided by 8. What they meant was are not divisible by 8. So if you want to say divided, you have to say divided by 8 exactly, because that's what divisible means. Divisible means you divide into it and it's a whole number. Now I know that seems really petty, but it is a really clear distinction between divisible and divided. So you have to be really careful with your wording here. If you want to write divided, you have to write divided exactly. And a last point here on modelling. So the last part of this question is asking you to explain whether or not this fact supports the use of the linear model. Now, in this case, the answer is yes, but you can't just say yes. You have to explain really explicitly why and how that relates to the information you found. So if we look at the answer on the left, he says yes, and says that they found the actual height to be 1.4, which is quite close to 1.42. And because they've mentioned both of them and that they're quite close to each other, then you'll get 2 marks for that. So the 2 marks are basically for saying yes with some appropriate working, but the second mark is for showing that from those appropriate working, the answers are quite close. So if you look at the 2 answers on the right, they both say yes, and they both work out 1.42, but neither of them say that 1.42 is quite close to 1.4, so they wouldn't have got the second mark. So you have to make sure that when you're writing your conclusion for these kind of questions, you are relating it specifically to information you have found and information from the original question. It's all about the accuracy of the detail for some of these questions, and there is a lot more writing than you think in the exam, so you need to think carefully about what you're writing and making sure you're actually answering the question that they're asking you, and really specifically. So some general advice. Read the question at least twice, and then read it again at the end to make sure you've actually answered it, and make sure you answer the actual question. I know it sounds silly, but I really often see people that just haven't actually done what they've been asked to do. So just stop and think, what is this question asking me to do? What are they assessing? What skills do I need to show? Check for the form of the answer. So if it says exact, that means thirds, fractions, or in terms of pi generally. And it means that you need to make sure your answer is given in the exact form, or they won't give you the answer mark. Now, this is something you would have got away with at GCSE, but you will not get away with it here. A very common one is if you're asked to find the equation of a line and they ask you to leave it in the form ax plus by equals c, they mean it. They'll take the mark off you if you don't do it. So just when you've finished a question, reread it and check that you've actually answered it and that all your answers are in the correct form. If you are in any doubt, show more working out. If you're in any doubt about whether you can use your calculator, do it by hand and check it with your calculator. It is always better to have more than less. Check with your calculator where you can. There are loads of things you can check numerically, and it's a really good habit to get into. So differentiation, integration, summation of series, all of these can be done on your calculator. Equations can be solved on your calculator. Not that you should be doing it just with your calculator, but you can always be checking them. If in doubt, do it by hand and with a calculator. That's the gold standard of how we're going to get these marks. Check your answers for reality. So just at the end, just read it back, especially if it's a question in context, and think, does that make sense? I think the classic example I always use of these is a student that once calculated the mean weight of a 12-year-old girl, and their answer was 1,842 kilograms. And I said to them, does that seem right? And she was like, I think it's fine. And I'm like, you think a 12-year-old girl weighs 1,482 kilograms? And obviously they'd forgotten to divide by the number of girls. But if they just stopped for a minute and thought, hang on, that sounds really big, then they would have had the opportunity to spot that mistake themselves. So once you get an answer, just stop for a second and think, does that make sense? Should it be positive? Should it be negative? Should it be this large? Should it be this small? Those kind of questions. I would say never cross anything out. If you're not sure, work side by side on multiple methods. When you're stating a conclusion, state it really clearly and fully. And if there are numerical results that you've worked out, make direct, specific references to them and relate it back to the question. Always give units for answers where appropriate. Usually these are just questions that are in context, and don't expect to be asked to do this. They're not going to remind you to do it at A level. They would have done it at GCSE, but they will not remind you to give units. And don't be sloppy with notation, especially with trig and calculus. You have to show what you're doing and you have to do it correctly. And you need to get into these habits now. Habits like checking your work and using a calculator to check your answers. As soon as you finish a question, you should read through it again, all your working, to check that you've done it right. And then if you have time at the end, you should be doing that again. But these are not habits that you can expect to suddenly pick up on the day. You have to start doing it now, so that when you're on the day and you're, perhaps quite stressed, that those habits are there and they will come to you naturally. It's really important to start doing all these things now. Okay, I hope this is really helpful. Good luck in your exams.